Hi everyone, thanks for coming out to Nerd Night. My name is Stavana Strutz. I'm a climate change biologist, a disease ecologist. Thank you to Nerd Night for having me out here. Thank you to you nerds for coming. And thanks to Andy for actually being a really good intro talk for my talk, because they talked about climate change and a bunch of the microbes that I'm going to talk about, so that was pretty cool. I was happy to see that. So, after I finished my PhD at UT Austin, no hate to Aggies, several of my uncles went to A&M. Honestly, I'm like, how many people from my program are watching this? A&M would have been the more practical program for me to go to for my PhD, but we went to UT. We made it work, though. Anyway, so I finished my PhD, and then I did some science communication. I helped co-found a science writing nonprofit known as Austin Texas Science Communicators. Some of those folks are here if they'd raise their hands. Yeah, woo! So yeah, they have a book club every month, and we do happy hours. So if you're into science, come out to our science communicating nonprofit. And after that, I joined up with the Intergovernmental Panel on Climate Change. Raise your hand if you've heard of the IPCC. Okay, a few people, that's good. And I worked on that for about 3 years, and I'm a co-author on the most recent report that came out. And I worked mainly with Chapter 2, which was Global Terrestrial and Freshwater Ecosystems. So I looked at parasites spreading all over the world, except for in the ocean, or well, maybe on the coast, but not in the deep ocean. So here's a picture of the book. This is the summary for policymakers. If y'all are wanting to check out the most recent IPCC report, I suggest checking out the summary for policymakers unless you're a climate change scientist. Our chapter alone was like 180 pages. So the whole report itself, or just the working group 2 section of the report, was like 3,000, and there's 3 different working groups. It's a huge document these days. Okay, so as we've learned a little bit, climate change has impacts on various ecosystems. We can go back to grade school and think about the who, what, where, when, and why. So who is climate change impacting? Well, it's impacting the species that live on this planet, right? It's impacting biodiversity, it's impacting plants and animals and fungi, microorganisms. What is it impacting? It's impacting the processes of these microorganisms, what they do to live. It's impacting where they live. Some species are moving closer to the poles, moving northward in latitude, and moving upward in altitude to either try and find the remaining cool areas that they've evolved to, or to escape the hot areas. When climate change is not just impacting where organisms are occurring, but it's also impacting their temporal dynamics. So it's changing the seasonality of events. You've noticed this in Texas. It's like hot until December now. So we have these like longer seasons, and if you're a parasite or a disease organism, you're a virus, you're a bacteria, you're a helminth pathogen, you're a parasitic worms, not all are bad. Now you get to like reproduce multiple times in a year, when maybe you used to only like replicate once or something, and now you have 3 reproduction cycles. Why is this happening? Anthropogenic climate change. We're putting more carbon dioxide out into the atmosphere. And then also, like Andy was talking about, we're disrupting the soil, and that's releasing large amounts of carbon as well, as we dig up swamps and we do, you know, burn and slash agriculture, and we destroy those carbon sinks that are all over the globe. And then how is, you know, the mechanistic dynamics of how all this works. And so this is happening for organisms that aren't parasites. So of course it's going to happen to the organisms and the other things they carry, right, those diseases. And I should mention, when I say parasites, I am trained as an evolutionary biologist. So a parasite for me is anything that's hurting the fitness of a host organism that's not a predator, not like big, right? But a lot of people in the microbial world think of parasites as like protozoa or like eukaryotic microbes. Oh yeah, we just said this. Okay, so here we have a cute picture of some cute little fuzzy animals. These are all local Texas biota. We have a, fox, coyote, cotton rat, raccoon, a deer mouse. These are all carriers of several pathogens locally, like Chagas disease and leishmaniasis. But that's not important. I just wanted cute pictures up here. Most emerging infectious diseases come from animals. So there's estimates that about 60% of human diseases come from animals, and up to 75% of newly discovered diseases within the past 30 years have come from animals as well. The main diseases we're worried about with climate change are those spread through the fecal-oral route, which makes sense if you think about climate change impacting hydrological cycles, more flooding, sea level rise. Now we're washing all that poop into the water system. And also vector-borne transmission. So these are pathogens spread by blood-sucking mosquitoes, sandflies, kissing bugs, ticks. I hate ticks. They're like my most hated of the different vectors, by the way. Yeah, fuck ticks. I don't know if I can curse. But I mean, and we like the possums for eating them. So over here, speaking of vectors, this is a sandfly. This is one of the organisms I used to study. They're like 1 millimeter in length. I did sampling all over Texas to 69 field sites. And then this is the disease they carry, leishmaniasis. It's a cutaneous disease here locally, at least. It's been spreading north from South Texas all the way into Oklahoma in the past 30 years. It jumped like 650 kilometers north during the 1990s and 2000s. And obviously you can see it infects like cats, rodents, dogs, people. Let's see what I was going to say next. All right, so how does climate change increase disease risk? Well, one, you get new diseases in new places, like with leishmaniasis. It wasn't documented in the Dallas-Fort Worth area before. Now it is. It used to be like at the tip of Texas, Cameron County, South Texas in 1903. It circulated around San Antonio in the 1980s and then jumped up, and we don't really understand why. We're also going to have more frequent and larger outbreaks, right? We have these longer transmission seasons of suitable weather, which we'll talk about, or suitable climate in a minute. And then what I just said, longer shifted seasons of transmission. So let's get into the dynamics of that. And this is a cool infographic I worked on with the IPCC that's in our frequently asked questions. So in the IPCC, right, it's super technical. You can read the summary for policymakers. That's more layman terms for like government officials and regular folks. Then there's like the meaty, like really technical report. And then we have these things called FAQs, FAQs, frequently asked questions. And those are supposed to be written at a level that is easy for teachers to read or share with their students. So, you know, feel free to look at the report and pull out those facts if you're an educator or something and use them. But, you know, diseases get into human populations all the time. Unfortunately, we've been seeing this with COVID, with the precursor, SARS, back in like, when was that, 2009? Like all the people that study parasites and epidemiology were like, we know one's coming, and then, you know, Trump dismantled our pandemic response force, and so then we were just super screwed. Anyway, so there's lots of factors that worsen diseases. Things like poverty, war, increased travel and trade, poor public health and low vaccination. And it makes it possible for us to interact with these other domains in the environment. So now we have like folks interacting more with agricultural systems and wildlife systems. And all of these things damage these systems and create zones where diseases can be transmitted. And then if you're wondering like what are some, you know, off-the-cuff examples of ways climate change increase disease risk, droughts increase unsafe water storage or usage, which can lead to more fecal and mosquito-borne diseases. Like, you might think, oh, drought, you know, that's gonna reduce mosquito-borne diseases, but not if people are storing water. And it might increase the fecal pathogens because now there's not enough water to wash anything. And they've even linked rabies outbreaks to droughts because now you have more animals clustering around limited water sources. Floods obviously increase mosquito habitat and cause sanitation problems. But just like with droughts, the effects are not always clear. For instance, floods can also wash away stagnant standing water that would host mosquitoes as well. So when you study the climate change effects on parasites, you really have to look at the magnitude and frequency of these events. Sea level rise increases the risk of cholera. Heat waves increase pathogen and vector development. We'll talk about that a little bit more. And then storms overwhelm or destroy water infrastructure, increasing fecal diseases again. And one thing that's really awful is that, like, A lot of our energy resources are on ports, which is great. This is just a side note. But we really need to be moving things inland away from these storms. Like Houston, why are all our like refineries right on the coast in Beaumont, you know? It's very concerning. Oh yeah, sorry, my talk may not be happy. I don't know. so drink up, tip your bartender well. All right, so I talked a little bit about pathogens moving. Where are they moving? They're colonizing historically colder areas, emerging infectious diseases. So ticks are moving to temperate regions, they're moving into polar regions, they're moving up mountains as that habitat becomes hospitable to them now because it's warmer. Heat waves can lead to outbreaks of helminth pathogens. For instance, microfilariemia, we're gonna talk a lot about worms. If you read the little like talk blurb, I talked about the wormageddon, like worms are gonna be real bad with climate change. I like that you talk about UV radiation, because UV radiation is like bad for worm parasites in the soil, as it is for other organisms in the soil. And so like several worms are not just found in the soil, they can also be spread by mosquitoes and flies by blood-sucking organisms. So reindeer are getting like super screwed by these high temperatures and these worm parasites, and we'll talk more about reindeer in a little bit actually. And then we have seafood poisoning getting worse, and people getting cuts when they're going swimming in these like shallow bays on the coast of Texas that get infected with vibriosis. So, you know, be careful out there. Okay, so this was a cool case study. So Nepal, you know, a Himalayan country, has very high altitudes, has lowlands in the south here in this green area, and it gets and then it gets higher, right? We have hills and then mountains. Hills are like these dashed lines. So these are several different pathogens. Here we have leishmaniasis, then we have Japanese encephalitis, malaria, dengue, and another visceral leishmaniasis. Oh, sorry, this is lymphatic filariasis. Not that y'all know what I'm talking about. Worm disease, mosquito virus, mosquito protozoan parasite, mosquito virus, and protozoan parasite spread by sandflies. So anyway, you might not be able to see this very well, but you can see little like triangles here. And those little triangles are saying like, hey, these areas had this disease back like before the 2000s. All of these red arrows are showing more cases of the disease between like 2004 and 2012. So basically what you see is like the cases were in the lowlands in the green area, and then suddenly they're like popping up in the hills, and sometimes they're getting into the mountainous regions. So it's a problem. It's just we have evidence of like these diseases moving. It's already here, it's already happening. We need to be adjusting our public health infrastructure for this stuff. And so, you know, we talked about them moving. Now we're talking about their magnitude. They're becoming a lot more severe. These warmer winters, for instance, allow greater survival of the things that like to bite us and spread these diseases. They're not getting killed off by the freezes anymore. That's why it's like we get the freeze in Texas and our power goes out and I'm like, yeah, fewer bugs. But it's all a cost-benefit analysis, right? You win some, you lose some. So these warmer winters are increasing the transmission seasons of these parasites and their hosts. And P.S., when I say vector, that I'm referring to an insect or arthropod that transmits a pathogen, a thing like a tick, a mosquito, a kissing bug, a sandfly. And so these warmer winters, the vector populations are also increasing because they're not dying. Like, it's very obvious. And then if you have more of these insects that are good hosts for the parasite, the parasite load's going to increase as well. And then you're also increasing more of those organisms that are infected. And so, for instance, there's this nematode lungworm, I'm not going to say that, that cut its development in half. Normally it takes 2 years to mature. Now it's been sped up. It matures within a year. So it's, you know, just going through these muskoxen populations here in North America. And interestingly enough, related to biodiversity from Andy's talk, there's this hypothesis called the dilution hypothesis, where if you have more biodiverse habitats with more specialist species versus like generalist species like your random black rat, your brown rat, your skunk, whatever, if you have more biodiverse ecosystem with more species, not all species carry parasites and spread them as well as others. And so biodiversity can protect you from diseases, just FYI. Worms. Okay, let's talk about worms. I was not into worms before I started working with the IPCC, and then I got really into worms with the IPCC. So one of the problems we had when we were doing this report was finding good sources of data that went far back, looking at pathogens, because it's really related to like the public health system setup. When you're looking at data to support climate change processes, you need like long temporal trends, and you need like large areas. While case studies are helpful, it's helpful to have bigger areas to look at. And we had a lot of trouble finding this data. That's one reason I went to like so many field sites in Texas trapping sandflies and rodents and looking for leishmaniasis. But guess who had good data? Anyone have a guess? I mean, you can look at meat, right? Like there are agricultural standards, maybe not here, but like in Europe, they care. No, they have stuff now, but, and I know some of you in the audience can actually tell me about it. But yeah, so they've been tracking meat since the 70s and looking at these like different worm parasites in the meat. And it's basically all going up. And they've looked at other factors like anti-helminthic resistance increasing, and it's not due to that. These like worm parasites are showing up further north in Europe as well. So that's a problem. Y'all are aware the Arctic is like getting super screwed right now. Most of the Arctic has increased by more than 2 degrees Celsius. It's a huge problem for many reasons. There are risks of permafrost melting, releasing like dangerous pathogens. There are some papers about that. It's mostly been like hypothesis, but there is like at least maybe here an example of that happening. And so let's talk about the Arctic and what's happening there. There's milder winters, right? So we have increased survival of the vectors, bad bugs, and their carrier animals, things like the deer mouse that might carry like Lyme disease spread by the ticks. The habitat is also increasing for things like these rodents and their vectors, because now you have forest expanding into treeless tundra, which is one of those funny things with climate change. People are like, just plant a tree. But like, you want trees in the right place. You don't want trees that are sucking up all the water being put into desert ecosystems, competing with other like water uses. And you don't want trees going into areas where they weren't necessarily there before, screwing up that ecosystem. We also have new vectors occurring in places. So ticks, mosquitoes, culicoides, biting midges, those are things that spread blue tongue virus. They're like those cute little tiny flies with the little feathery antenna that you might think are pretty, but they might be biting you. Deer flies, horse flies, and Simulidae black flies. Here is I think this is a horse fly. And then we have these new diseases showing up in places where they've never before been documented. They've either never before been documented, or they're happening at such high rates. It's kind of nuts. So things like anthrax, which we're about to talk about because everyone likes hearing about anthrax. Cryptosporidiosis, this is a fungal disease. Elephostrongyliosis, which is a worm parasite. Filariasis, worm parasite. Tick-borne encephalitis virus, and tularemia bacteria. What's really cool is like our CDC was born out of a government program from the military to keep our troops alive. Because we used to have malaria all over the southern United States. It came over with the slave trade. We had yellow fever. And most troops were dying of diseases rather than like wartime injuries. And so the military started draining swamps. They started doing this stuff when they were building the Panama Canal. And they were actually able to eliminate like malaria and yellow fever from the United States and make all these great breakthroughs in the mid-century. And one of those things they also were able to get rid of was tularemia. But we've kind of fallen down on the job. We need like better infrastructure. We need a lot more surveillance. They also use DDT, which, that's not always great. But okay, so, oh yeah, I'm sorry. Here's a dead reindeer. I'm sorry, I should have warned y'all. This little dude died of anthrax in this place, the Yamal Peninsula. This is in northern Siberia. Oh, there we go, anthrax. Everyone's scared of anthrax because they remember the like Senate scare. When was that, like in the 2000s? Thank you, yeah, 2002. But anthrax is a naturally occurring organism found in the soil. It's found in the soil of West Texas. It's found all over the United States. It's found in grasslands. It's often associated with root nodules of plants. There's some interesting ecology there. Bacillus anthracis. But unfortunately, permafrost has been melting at staggering rates and exposed disease animal carcasses, likely releasing this thawed and highly infectious bacillus anthracis. Never go near a big bloated dead animal. I'll just say that. Like if you're out in the environment, don't go poke dead things that are bloated. Or dead things, like this guy's not bloated, but he's got anthrax. So just be careful if you're into taxidermy. Okay, so why was there like this perfect storm for an anthrax outbreak on the Yamal Peninsula that killed thousands of reindeer, killed a little boy, killed multiple reindeer herders? One, the permafrost had been thawing for 5 years preceding this 2016 anthrax outbreak. Snow cover, and this is one of those weird counterintuitive things about these phenomena, snow cover was actually high the winter before. Guess what the snow cover did to the warm ground? It insulated it, so then the permafrost didn't refreeze. At the same time, there was a public health failure of fewer anthrax vaccinations and increased reindeer population. And this is how you have these like compounding disaster events, you know, like climate change is fueling this, but we are also falling down on the job. There was a hot summer, and then boom. Now there's all these carcasses exposed and like anthrax spores. Now there's a higher population of biting flies, because what do these vectors do when it's hot? They mate more, they go through more reproductive cycles. And then the reindeers are not really adapted to these hot-ass summers, and so their immune systems are getting damaged, so they're more susceptible. And a side note that's really interesting with these reindeer is it's also just, the hot summers are also just bad for them because it damages their physiology. It makes them more vulnerable. So these hot temperatures increase our blood feeding insect populations, and now they just harass the reindeers. And what's interesting is like migration was is thought to have evolved for some organisms as a way for them to escape parasites and escape insect harassment. So they're like, oh, it's too hot here, let's go up, you know, let's go north and get away from these bugs. They go north, they don't get to escape the bugs because the bugs are tracking those warmer temperatures. Insect bite rates go up, but it means more parasites in the reindeer. Then the reindeer just like literally are running around trying to escape being bitten, and they're not foraging, and they're increasing their energy expenditure because they're running around all crazy. And then their body condition suffers, and there goes their winter survival, and it also reduces their reproduction. I'm sorry, y'all all look really sad in the audience right now. I wish I had something to make this better. Now you know. Oh yeah, here we go. What can we do? There we go. I feel like while individuals matter, we really need like social responses to these issues. We need like government responses. We need community responses. We have to work together to overcome this stuff. People always ask me, they're like, how screwed are we? Are humans going extinct? What can we do? And I'm like, you need a vote, and you need to organize, and you need to work on making your local community resilient as well. But we'll go through some of this here. Okay, so one thing that's really important is habitat and biodiversity protection. Humans get around, right? Like, we're super highly connected right now. That's why a jet from the Middle East flew to New York in 1999, introduced West Nile. Some mosquitoes were in the wheel well, and then West Nile spread across the United States to California in like 5 years, just from this like one introduction in New York. Like, these diseases move quick. Those horrible stripy mosquitoes that land on you and bite you, Aedes aegypti and Aedes albopictus, the Asian tiger mosquito, those came in on some tires in Houston, like a shipment overseas. Problematic. Anyway, so we have increased human movement, and that's increasing our contact with all these different organisms and leading to opportunities for disease spillover. Disease spillover is when a pathogen in one organism jumps hosts and shifts into a new species. So agriculture and livestock, the more we like make farmland in new areas, we're cutting down forests, we're moving cattle and other animals into these areas, we're gonna have more interactions for parasites. Timber harvests, mining and resource extraction, urban development. So like really learning how to live a little bit more within our means and within the land we've already disturbed would be helpful to reducing future outbreaks. We also need to conserve and restore wild habitats so we can build healthier ecosystems that affect other climate change issues like, hey, we like having clean air and water, right? Like carbon storage, so the planet gets a little less hot. I mean, we are on a bad trend right now, like a bad forecast that we really are gonna have to work hard to reverse or even minimize, mitigate. And like, I like to go camping, you know, so having these places, these wild places that are restored and protected improves human recreation and well-being if you wanna be selfish about it. But if you're going into those areas, you know, you need to take personal precautions. So wear protective clothing. When I used to do field work and I was trapping this stuff, it was like long pants, socks, my pants tucked into my socks, boots, okay. Shirt tucked into waist, because those ticks will just climb up, and then if there's like a gap, they'll just crawl up into your armpits or your crotch. It's not pleasant. I suggest using like insect repellent with chemicals in it, permethrin. Right. So I got so excited about the insect repellent, y'all, to throw my maybe we'll pass this. If someone wants to just kind of punch through on the presentation. I lost the battery, y'all. Does someone want to just hit the forward button a few times? You can just fill up this whole screen. Yeah, so do body checks for vectors like ticks, wash your hands and clothing well. That's in case you're coming into contact with like urine or feces in your environment. We have hantavirus in Texas. We have plague in Texas. Like, we have a lot of nasty stuff here. If you want to know what it is, come talk to me after or look at my old talk. I did a Nerd Night talk like in 2012, the 33rd Nerd Night, where I talked about tropical diseases expanding in the United States. And vaccinate yourself and your pets and put like flea prophylaxis on your pets. One of my friends actually caught typhus this summer and nearly died and like has really suffered quite a bit. He's doing okay now from a flea bite because he caught typhus. Typhus always increases in Texas whenever we have a lot of rain, because a lot of rain means high rodent populations and higher flea or chigger populations. I bet a bunch of you didn't know that chiggers can give you typhus. So another word to the wise, if you ever have like really bad flu-like symptoms, a high fever, and a rash, and you've been bitten by something, or you've gone camping, or you've been doing a bunch of yard work, or hanging out with random animals, go to your doctor, because you might have a really bad vector-borne disease. Rash, flu, high temperature, just so you know. And you know, besides being selfish in a good way, you can make your community safer. So we want to get rid of mosquito habitat, dump those containers with standing water, your flower pots, your like little random bowls or trash in your yard. Use anti-mosquito dunks in standing water, or you can add mosquito fish and local mosquito predators to container ponds, or build healthier, more biodiverse ecosystems. You can improve housing, have screens on windows, better insulation. It was really interesting in Houston, like a decade ago, they found a bunch of people that had antibodies to dengue in their body, like within like a homeless population or people that had substandard housing, and they'd never left the Houston area, but they had dengue antibodies. We have dengue in like, well, it may be more counties now, but it used to be 4 counties in southern Texas on the border. So like these things, Texas is getting hotter, we're becoming more tropical. Like we're the southernmost state besides Florida, and so we're gonna see a lot of these nasty things before other places. And we need to improve public health surveillance, which requires a lot of government involvement and allocation of resources, which like you hope with COVID, that's gonna be important now and prioritized. So with the Spanish flu back in 1918, 1919, it was terrible. You know, it killed, what, like 60 million people? Does anyone know off the top of their head? But that paved the way for a bunch of this virology research that came out in the decades afterwards. It led to it paved the way for some of these like vaccination breakthroughs. So my hope with COVID is it's been like a wake-up call. We're gonna respond better in the future. And I think like this will complement the other talk well, like improving our food resilience is really important. Investing in sustainable agroecological farming, so using ecology to guide agriculture. This alleviates hunting. Hunting is a source of various pathogens. As you're hunting wild animals, you're getting their blood on you, you're eating them. Sustainable agroecological farming reduces this extension of human habitat out into wild habitat through agriculture and livestock. We need to stop illegal animal trade and poaching and decrease reliance on wild meats and products made from animal parts. Then just like the other slide where I talked about the benefits of like conserving and protecting biodiversity in spaces, right? There's benefits of having increased food resilience, better nutrition, more food security, better soil and reduced erosion, biodiversity preservation, and then climate change mitigation and adaptation. So, it's like doing one of these things improves our health all around. It's really important. And then for disease prevention and response, we need to make some big social changes. We need to improve our education system so people understand what they're reading and take appropriate safety measures for themselves. We need to build high quality medical and veterinary systems with access for all. We need increased food security, proper sanitation of water and waste, high quality housing that is actually maintained, not just built and then left to like rot and break down, disease surveillance and alert systems. And then this framework we call One Biosecurity or One Health, where we're basically incorporating like the animal environment human interface. So we're looking at the agricultural system and its connections to the human system and its connections to the like wildlife or pet animal system. And then this is a table we made for the IPCC report. I'm not going to go through all of this, and we actually have like updates to this stuff that I want to work on. But these are some of the different things we can do to make our communities, our world, our nation safer in the face of climate change. All right, so yeah, some techs and bugs. Happy to take questions. You can find me here.
All right, fantastic. Okay, so first question. Let me start in the back. No, everybody back there's quiet. Okay. Here's a good question.
Welcome back. Are there ticks in Austin, and are we going to get them if not?
Are there ticks in Austin? What's the second part?
And if not, are we going to get them?
We do have ticks in Austin. We have ticks all over Texas. Some will argue that we do not have Lyme disease present in Texas, but we do. We also have other tick-borne infections like starry. I think Rocky Mountain spotted fever's out in West Texas, maybe near the tip. But there are lots of tick-borne pathogens around, and they are constantly evolving. Like, they discover new diseases all the time. So yes, we have ticks here. Be careful in those wooded areas. They're maybe more problematic when it's a little wetter out. The winter, or not the winter, the fall months are when you have like juveniles becoming active and they've reproduced. I don't know if you've ever seen seed ticks. It's kind of a nightmare. I know there's ticks in Texas because I've gone out in the field and they've covered my like pants. That's why I feel like that's one reason biologists wear khaki, because like you look down at your leg and there's like a bunch of little black pinpoints, like 100 of them crawling up your thigh slowly, and they're baby ticks, juvenile ticks, and then you just get them off. So yeah, I'm sorry to answer your question. Oh yeah, feel free to ask me about weird bugs around here if you're like, we don't want to know about global climate change. What do I need to worry about in Texas?
So where should we move to avoid as much of this as possible?
So FEMA actually has like a really good disaster map out of like areas and how resilient they are to climate change and other disasters like hurricanes and tornadoes and whatever. I can't say just for diseases, because it kind of seems like nowhere's safe from diseases. I mean, to be fair, in Africa, for instance, while here's one good thing about climate change is making it so hot that the malaria parasite cannot replicate in mosquitoes. But that just means it's better for dengue. So we just have like different parasites like stepping in to take over the places of these other ones. But actually, in answer of your question, the Northeast is supposed to be good, like Massachusetts and Maine, maybe parts of Appalachia. But then we also are predicting hurricanes to hit further north. So you're more likely to get hit hurricane up there in like Maine and Massachusetts now than you ever were before. As we saw with this hurricane that hit California, for the first time in a century or something.
Next question. Anybody else? Okay, one more question.
There's one in the front too.
Okay,
Come find me after if you.
great.
You don't.
Oh, you were pointing. Who are you pointing to? Oh, right. Okay.
Thank you to our interpreter because I know I talk fast. So she was
Hi
having to
there.
keep.
Thank you for a great presentation. I was wondering, have you seen the TV show The Last of Us?
Yes, I have.
What's your opinion on that?
Okay, so I love the zombie literature. I'm a big zombie fan. I'm actually been taking some science fiction writing classes. I have some ideas about like apocalyptic pathogens, and I am going to put zombies in my book. I think that it's unlikely that fungus would actually, it's unlikely that that would actually happen. But I was glad to see some like diversity in the zombie literature. There's like a fungal one. I don't know if any of y'all have read The Girl with All the Gifts, and there was a movie made for that. That's another good like fungi zombie movie that most people don't know about. Yeah, it was cool. Cordyceps, like you can eat that though. Like they sell that like that taxa of mushroom like in grocery stores in certain places. So they won't turn you into a zombie.
Well, I personally want to thank you for assuaging my fears as a mycophobe.
We like fungi. We've learned the fungi are good.
They're great, but you know, I don't like them. All right, I believe that is it. One last question.
Here locally, what do you see of what's working and what's not working in terms of disease prevention?
What do I see that's not working? Okay, let's see here. Unfortunately, like antibiotic-resistant tuberculosis is like a problem. Just a lot of our like public health systems got kind of slammed during the pandemic in terms of like funding being reallocated towards COVID and taken away from other programs. I don't know, it's not good. I'm wanting to put together a talk about STI as well because there's now like antibiotic-resistant gonorrhea hiding out in people's throats and stuff. So like there's bad stuff happening. Follow my page, my Stavana the Scientist page on Facebook, and you can also ask me questions there and maybe I can do a little more research and answer them. So yeah, thank you, y'all.
All right, thank you.